Hey Pre-Calc, we're back for part 2 of section 1.3. The instructions on these next 3 examples are all just factor the polynomial with the structure intended. I'm going to skip number 23. It's about factoring cubes. I just kind of decided I'm not going to do that right now, but it might be worth talking about in class. So expect that. Number 17. So there really isn't much difference between the previous example we just talked about. It's a polynomial of 3 terms, x squared, x constant, classic quadratic formula, or not quadratic formula, just quadratic. Normally I just say go for the AC method, but when you take a look at this, it's kind of like 36 times 25, and that's a really big number. 36 times 25 is, oh man, what is that? I think it's 900, right? Because 136s would be 3600, and 25 is kind of like a quarter of that. So a quarter of 3600 is 900. All right, and it's got to add up to a negative 60. So this is kind of a rough go if we're just going to like go through every single set of factors that works here. Keep in mind that in order to multiply to be positive and add up to be negative, both the factors have to be negative. So here's the deal. Look out for this kind of special case. 36x squared is a perfect square. Yeah? 25 is a perfect square. In certain situations, you can use 6x and 5 as your factors that kind of make things up. If you're not seeing that, though, we'll eventually get it till the end. So factors of 900 that add up to negative 60, I'm just going to throw this out here. Perfect square here, perfect square here, perfect square here. I think it's to our advantage to actually, I don't know, see what the square root of 900 is. 30. What's 30 plus 30? Oh, it's 60. All right, so in this case, we had something special. Negative 30 times negative 30 is positive 900, and it adds up to negative 60. We got our factors. So if we went through this the normal standard way, negative 30x here, negative 30x there, bring down the plus 25, bring down the 36x squared. Then you're going to group the first 2 terms together. They both share a 6 and an x. Take it out. The leftovers, by the way, I'm getting the leftovers by dividing by it. Hopefully that's clear from the video here. 6x minus 5 remains inside. Over here, remember when you're factoring that if you've got a minus and a plus for this group, but you had a plus and a minus for the first group, whoa, you got to take out a negative to create the plus-minus situation so that their 2 leftover groups match. You can take out a negative 5 then, which leaves you with a positive 6x and a minus 5, which leaves you with 6x minus 5 times 6x minus 5. And there's the special case. If the first one's a perfect square and the second one's a perfect square, there's a chance that this kind of not like difference of squares factoring, it's called perfect squares factoring, can actually give you something to shoot for. And you know what? Sometimes your best bet is to guess this and then check it by multiplying it out. 25. All right, you got 4 terms here. So the first thing that you really should start talking about is there a GCF I can take out of this? And really, I should have been preaching that for every factoring example. Taking out the greatest common factor is always the first step for it, if you can. So, it contains a factor of 3, which leaves you with x cubed, x squared, negative 9x, and negative 9. All my markers are trash. I got to get some new ones. Now, remember when we did factor by grouping once we created the 4 terms? That's the whole purpose of creating four terms. Four terms is all about factor by grouping. So if you see a polynomial right now that's been rewritten with four terms, factor by grouping. So these two go together. They both share an x squared. The leftovers, divide that by x squared, you get x. Divide that by x squared, you get a positive 1. Look at these two, take out a negative 9, and you should be left with, again, x plus 1. The 3 is just chilling off to the side. We'll bring the 3 back in at the end. This gives you x squared minus 9 times x plus 1. We were just talking about difference of squares factoring. This is a difference of squares. So it doesn't just work in the way of moving forward like when you multiply, but when you're trying to factor, make sure you're taking into account that this factors down to x minus 3 times x plus 3. Right? When you have a difference of squares, all you got to do is square the first one, square the last one if you're multiplying them. I'm just using that logic in reverse now. Times x plus 1, and then the 3 comes back, and it's completely factored. I glossed over the difference of squares. If you really need to look more into that, check out YouTube for difference of squares factoring. I'm sure you'll find something nice. Find something that's effective. I'm sure you'll find it. You'll need difference of squares factoring to do this number 27, and I modified it from the textbook. It's not number 27 from the textbook, but it looks a lot like it. So it's not 27 at all. It's this. So being able to factor a to the 16 minus b to the 16. The first thing to recognize is that it is a difference of squares. Difference of squares. If it's a difference of squares, then you just have to ask yourself, all right, what times itself gives me a to the 16? The common error is that students will think it's a to the 4 power. It's not a to the 4 power. Think about what happens when you take a to the 4 times a to the 4. The rules of exponents say that you add the two together. That would give you a to the 8. We need 16. So what should it be? This one should be a to the 8 times a to the 8. B to the 8 times b to the 8. And difference of squares is a minus and a plus. And there you go. But we're not done yet. Difference of squares again. Like we said before, a to the 4 times a to the 4 gives you a to the 8. So a to the 4 times a to the 4. B is pretty much working at an identical pace. Now here's the tricky part. I'm not going to go into this in depth in this video, but these two perfect squares, a to the 8 plus b to the 8, they do not factor down in the same way that the subtraction between them works. It's just unfactorable. So, you drop it down, and it just kind of remains as a dormant part of the factoring experience. And that's the same for this one here too. It's done. It's not going to do anything else but just kind of hang around. Now the a to the 4th minus b to the 4th, these are also difference of squares. A squared times a squared gives me a to the 4th. B squared times b squared gives me b to the 4th. And then these two drop down as well. You know what? I think I'll just wait till the very last step to rewrite the whole thing in order, because we got one more factoring to go. I'll just draw a little arrow to indicate that it is happening. But here's my last one. A squared minus b squared is a minus b times a plus b. and now it's completely factored. So the a squared plus b squared is a part of it. A to the 4 plus b to the 4 is a part of it. And can you see the whole thing? A to the 8 plus b to the 8 is a part of it. All right. I'm going to take these last two examples, number 81 and 89, and do it in its own separate video. They're just kind of funky, and I think they should be aside from these other ones.